In this lecture of maxima and minima, we will understand the terms absolute maximum and absolute minimum values of a function in a closed interval, and hence we will understand the working rule to find these values. Consider the function f of x is equal to x plus 3, where x belongs to the open interval 0, 1. Clearly, the function is continuous in this interval. But how about the maximum and minimum values? Here, x belongs to the open interval 0, 1. Therefore, fx neither has a maximum nor a minimum value. Also, observe that this function is clearly continuous on the open interval 0, 1. And also, it does not have a maximum or a minimum value in this interval. Also, observe that this function does not even have a local maximum or a local minimum. However, if we redefine the domain of the function as closed interval 0, 1. That is, instead of open interval 0, 1, we are redefining this domain of the function as closed interval 0, 1. Then this function has a maximum value at x equal to 1 and it has a minimum value at x equal to 0. This minimum value at x equal to 0 is called the absolute minimum, and it is f of 0 which is equal to 3. And this maximum value is called the absolute maximum value, and it is f of 1 which is equal to 4. Now, let us consider the graph of a continuous function fx in the closed interval a, b. Observe that this function is defined in the closed interval a, b. Observe the points D, G and H. These points are the points of local maximum. Also, observe the points C and E. These are the points of local minimum. Now, we will highlight the points H and A. See that the point H is the highest since its ordinate f of h is the greatest. Therefore, this is called the absolute maximum. Similarly, the point A is the lowest on the curve since its ordinate f of A has the least value. Therefore, this is the absolute minimum of the function. Now, we will see two results or theorems without proof regarding the absolute maximum and absolute minimum values in a closed interval. The first theorem says, let f be a continuous function on a closed interval I equal to a, b. Then f has the absolute maximum value and f attains it at least once in I. Secondly, f has the absolute minimum value and f attains it at least once in I. The second theorem says, let f be a differentiable function on a closed interval I equal to a, b, and let C be any interior point of I. Then f dash C is equal to 0 if f attains its absolute maximum value at C. Secondly, f dash C is equal to 0 if f attains its absolute minimum value at C. Now, let us understand the working rule to find the absolute maximum and absolute minimum values. Step 1 is find f dash x, that is, find the first derivative of the function. Second step, put f dash x equal to 0 and find values of x and call them as C1, C2, C3, etc. Cn. Step 3 will be evaluate fx at these points C1, C2, C3, etc. Cn, where f dash x is equal to 0. That is, find f of C1, f of C2, f of C3, etc. f of Cn. Step 4 will be evaluate fx at the points where derivative fails to exist. Then step 5, find f of a and f of b, that is, evaluate f at the endpoints of the closed interval. Then step 6, identify the maximum and minimum values of f out of the values calculated in the previous 3 steps, that is, in steps 3, 4 and 5. The maximum value thus obtained will be the absolute maximum or the greatest value of f in the closed interval a, b. And the minimum value obtained will be the absolute minimum or the least value of f in the closed interval ab. Now, one observation before we wrap up the lecture. Absolute maximum is also called global maximum. Similarly, the term absolute minimum is also called the global minimum in the given interval.